let's make an effect here. Let's actually make our first effect, which is just going to be like a test, kind of an abstract water effect. We'll say we want some water beads to be forming on the ceiling, and eventually we want time to over time we want those beads to get big enough where they drip. And let's go ahead and let's just delete this and then create a new particle system, so we're starting off from scratch. And we're going to create a we'll delete init velocity, and then we'll right click and create a cylinder module inside of location. And I'm going to turn on 3D draw mode so we can visualize this a little better. And let's set its height to about 5, so it's not very tall. And then we'll change our spawn rate to, I don't know, maybe like 10 and 30. We'll try that. And then the lifetime, we're going to give it a really long lifetime for now. So we're going to start off with a lifetime of 10. And then let's go ahead and add an acceleration module. And again, by default, we don't have any values here, so we want to change this to constant. And just to help visualize this once more, we'll change it to -500 on Z. And it does exactly what I was talking about. The particles spawn with no velocity, and then suddenly, little by little, they get pulled down and they keep picking up speed. And you can see they get faster and faster and faster. And our particles have a really long lifetime here. So let's say we want this to collide with the ground, right? Because if this goes through the ground and it keeps updating, we're wasting processor cycles. But let's say this is for an iPhone game. Let's say that collision modules are incredibly expensive. We have to keep this on the cheap. So there is something called kill height and kill box. And the kill modules, we're going to use kill height, basically set boundaries to where a particle system can live. And then once it goes past that boundary, it just kills it automatically. It overrides anything else. It overrides lifetime. It overrides like a collision module or anything like that. So like most things, we can visualize this. So on the bottom here, we've got 3D draw mode. We'll turn it on, and it gives us this flat plane here. And if we want this as our floor, let's put it underneath it. So our height, we have our distribution here that's to constant. Let's set that to -200. And suddenly what happens here is our particles are dying. And the reason is it's not set to floor. So what's happening is anything above this kill height is being killed immediately. So our emitter is above it, so like nothing gets a chance to live because it lives outside of that. If I change it to floor now and turn that switch box, or check that box down here, what you see is anytime it tries to pass this boundary, now our kill height is telling it, hey, you can't live anymore. So this is really cool for optimization. It's a really quick way to get a particle to die if you know your floor, or if you need it to collide with something, but you have to keep it on the cheap. So we want these to hang like they're water beads that are getting bigger. And let's go ahead and actually change this material again, because we're using the default RGB crosshair. So let's go to our content browser, go to our materials, and I don't know, let's use FX orb additive and assign that. And then the initial size, I'm going to change this. Did I have something written down here? We'll just say, we'll change it to constant. I'm going to just guess and say like 10 for now. That seems pretty good. And honestly, you know what? Maybe this isn't the best texture to use. I'm going to change this to our glow orbs. So there we go. That works a lot better for something that's supposed to be like a water drop or a raindrop. So our acceleration now, it's set to -500, and this is still really slow. So I tend to use, with acceleration, really big values. So I'm going to change this to -3000. So we're getting a lot of pull down now, and we're going to leave everything else for now, and we're going to talk about how we can adjust acceleration over time. Like I said earlier, if I added an acceleration over life, these two do not play well together. The acceleration module is going to always override acceleration over life. So if I change this to constant, right, and all of these are set to 0, if this acted as a multiplier, acceleration shouldn't be working because acceleration should be canceled out. Excuse me. So I'm going to delete acceleration, and we're going to work only with acceleration over life. And again, this works more specifically in particle time. So in particle time, I want to go about 4/5 of the way through its life, and then I want it to then immediately start being pulled down by acceleration. And I want those particles to get bigger right as they're about to drop. They get to their full size, and then they drop. So let's start off with acceleration over life. So we can go ahead and make this constant curve so we can animate this. And I'm going to graph this so we can see it. And we're going to create a point. And the first point we're going to put at time 0.8, which is 4/5 of the way through, and leave outval to 0, 0, 0, right? So what this means is there's no acceleration 4/5 of the way through. So I'm going to close this one and then add one immediately after at 0.81. And then at 0.81, I want to activate acceleration on negative z, so negative 3000. That's the value that we determined before. So now let's wait. Remember, these particles are living for 10 seconds. You can see them, they're all spawning. And then right now, boom, they all just start shooting down. So that's pretty cool. We now can do this. We can see our graph over here too. We're going from 0.8 to 0.81. We're changing it to negative 3000. And we can now change our spawn rate because I think there's just too many of these lingering. And we'll change this down to like 5 and 10 as a range. I think that's pretty good. And then the lifetime, because these all start to fall at the exact same time, we can give this a range as well, so we can change it from min to 2, max to 10. So now you give it a second to start running, and then you start seeing cool, just random drops happening. And that looks really cool, right? That looks like water falling. So let's talk about the last part of it, where we want it to get bigger right up to the point where it starts falling. So our acceleration kicks in at 0.8. So what we can do is add a size by life, like we talked about. And then it comes with some default points. So we'll change our first one. We'll leave at time 0, but we'll start it off at 0.1. I'm sorry, we'll change our size to 0.1 for our first point. And then we'll change our second point to time of like 0.75, we'll say, so right before 0.8, before it starts falling. And we'll leave that to 1. So now if I turn off my cylinder, the 3D draw mode, you can see all these little water beads forming. They get bigger, and then boom, they fall. And then they go through and collide with our floor, well, our cheap collision, right? And then they die as soon as they go through there. So this is a cheap way of doing it with one emitter. There's obviously different ways of doing this. You could have done this similar to our Sparks tutorial, where we have an event generator that talks to other emitters. But again, that's computationally more expensive. So this is a really quick way to do a cheap effect. And honestly, again, this is just a really good beginner effect. We're finally starting to make stuff, even though it's not very visually impressive. But we're seeing how all these modules now interact with one another. So this leads us to the end of our first volume here. We've learned about the Cascade interface, the different distribution types. We've looked into the core modules like spawn, lifetime, initial size, initial velocity. We've gone into the material editor a little bit here and talked about the vert color node and the different blend modes. And then we really got into all our different core modules or essential modules, such as the initial location, sphere, cylinder, velocity, acceleration, and that led us up to our first effect here with our simple water drip effect. So for our future volumes, we're going to start getting into more complete particle systems. We're going to do our health pickup. We're going to talk about subframe blending and sub-UVs and flipbooks, so that'll lead us to different fire and our rocket trail and so forth. We're going to start talking about the orbit module, the ribbon module, so we can do trails, and then we'll talk finally about optimization. So thanks for hanging in there, and we hope to see you with our future volumes on visual effects inside of Cascade. And thanks again. This is Bill Cladis, and you've been watching 3dmotive.com.